So we have built this topology, the physical topology, to understand the configuration of BGP, one thing. Secondly, how do we advertise networking inside BGP through BGP? And we are also going to learn about eBGP, IBGP relationship, the configuration variation in eBGP and IBGP, and much more like next hop self, uh, and etc. I do not want to tell too many things that which we have not covered it. So we are going to start from very basic, and gradually we will move on to bigger stuff. One thing I want to begin with is BGP is a TCP based routing protocol. Because it is TCP based routing protocol, the neighbors need to be a reachable one. But the neighbor do not have to be directly connected. I would like to repeat. The neighbor in BGP if it is eBGP need to be connected directly. If it is IBGP need not to be connected directly. That is one thing that we are going to see. Secondly, if IBGP neighbor like router 1 and router 3, if you see, the relationship between router 1 and 3 is going to be IBGP. It's BGP only, but we call it as IBGP relationship because it is within the autonomous system. It may sound like, what is this? I know this. What's special in this? Why is he emphasizing this much? There's a big concept that we need to dig deep and know. That's why I'm repeating. You see, IBGP and BGP, they are not same in policy. Look at this. The default policy is eBGP need to be directly connected. Whereas if it is IBGP, need not to be directly connected. What does that mean in another word? This router 1 and router 3 can form neighbor without having BGP on router 2. Yes. Router 1 and 3 can form neighbor without we having BGP on router 2. Do you follow me? Can you hear me? I'm just checking whether we are connected.
Yes,
Oh,
yes,
okay, thank you.
I can hear you. I can hear you well.
IBGP need not to be directly connected. Here, no BGP. We enable BGP only on these two. And we can form peering, which is not possible in the case of eBGP. That's one thing here we are learning. I'm saying not possible. It doesn't mean that it is not at all possible. Default. Here, by default, I can form neighbor even though they are not connected directly, which is not possible by default when it comes to eBGP. In eBGP, if you have some router here, and when you try to form neighbor between these two, not possible unless you do some additional tunings. This is not possible by default. These two cannot form neighbor by default because they're not directly connected. See, sometimes people may have firewall here. Sorry, the router here and firewall here. And they want to form peering between R3 and let's say R5. This is R5, which will not be possible unless you do some additional tunings. For eBGP, the neighbors need to be directly connected. So let us see this thing first. What IBGP need not to be directly connected. But we also learned BGP is TCP based protocol. Now I'm asking you a question just to think. You don't need to answer also because you know the answer, and just to think. I'm asking a question. If R3 wants to telnet to R1, it is only possible if there is a reachability from R3 to R1, because telnet works on TCP. If R3 cannot ping R1, telnet is not possible. So what is needed for TCP? Connectivity. Only if these two are connected. We are not saying physically connected. It can be connected via router 2, that doesn't matter for us, but all that we need is reachability. If these two can reach, then TCP can reach. If these two can ping. Now, if R1 needs to ping R3, what is needed? OSPF. Or some IGP protocol. Any one of the IGP protocol. Or a static route. There should be some way to tell R1 how to reach R3 to negotiate this TCP BGP packet. TCP BGP packet can go and negotiate only if there is a path to reach the neighbor. So R1 needs to ping R3 and R3 needs to ping R1 in order to form BGP neighbor. Now there is a question arising when I say this in your mind. What is that? How is that? Why it is so necessary now BGP? Why I need to have BGP if OSPF is already providing reachability between R3 and R1? Why should I go for BGP when BGP has got nothing to do between R1 and R3? R1 and R3 is already pinging because of OSPF. What is the role of BGP? Nothing. Then why do I need BGP if they are already pinging? Answer is we are enabling BGP in R1 and R3 not for the reachability of those networks on R1 and R3. No. That's not our aim. We are not trying to provide reachability between R1 and R3 using BGP. Our aim is to bring these eBGP networks into IBGP. That's the role of border gateway protocol. Border gateway protocol is to bring the networks from outside, for which R1 need to be a neighbor with R3. Otherwise, R3 cannot give all that it learned from R4. R3 cannot give to R1. R3 cannot give to R1 if R1 is not a neighbor, BGP neighbor. R3 learns this network via BGP, and if you want to learn those networks on R1, that same BGP will give to another BGP, for which you need to enable BGP here. And we call that BGP as IBGP because they happen to be in the same autonomous system. Let's say autonomous system 10. This is autonomous system 20. So the role of OSPF is just to provide reachability so that this R1 and R3 will know where they are located, using which they negotiate BGP neighbor. After forming neighbor, what happens is the network information that is coming from outside via BGP is received inside autonomous system 10 through BGP only, not through OSPF. OSPF is not providing the 44, 44, 44 network. But R1 has already learned 44, 44, 44 because it has got another protocol, BGP. I repeat, without OSPF, R1 and R3 cannot form IBGP neighbor because BGP is a TCP based protocol. So, to provide that reachability in order to form IBGP neighbor, we use OSPF. To provide the reachability between R1 and R3, we use OSPF. When they are reachable, BGP forms neighbor by negotiation. After negotiating, they got neighborship. Because they both are neighbor, R1 and R3 are neighbor, whatever R3 learns from R4, R3 can now give to R1. Whatever R3 learned from R4, R3 can give it to R1 because R1 is a neighbor. Yeah, so it is BGP the one gave to R1. That is the reason why we don't see those networks in R2. We don't have BGP. No BGP. Because you don't have BGP, these networks are available only here and here, but not in the router in the path. Yes, this is possible because it's a TCP based protocol. See, when you telnet, for example, if you telnet from R3 to R1, will there be any telnet session maintained here? No. According to R2, it is one TCP packet, it is forwarding. It's just one TCP packet, it is simply receiving from one side and giving to other side. Sessions will not be maintained. Session is between R1 and R3 when you are doing telnet, isn't it? So telnet packets are not processed. It is just treated as a transit packet. It routes the packet from left to right and right to left, that's all. But who is processing the telnet? R1 and R3. Likewise. Whatever router 3 gives to router 1, even though it is going via router 2 cannot open it because it is not destined to R2. It is destined to the neighbor called R1. So whatever R3 sends to R1, R2 will simply forward it. It won't open and see the BGP updates because it's not a BGP running router. It is not a BGP running router. Using the OSPF reachability, it knows where is R3 and R1. So it will simply forward the packets of R3 to R1 and R1's packet to R3 if BGP is sending it. So a lot of kilometers to drive. We have just begun our journey in BGP. Let us begin from 0th kilometer. I'll start from R1, basic configuration. If you notice here, I'm not running OSPF on loopback 0 because I'm going to use that 1111 network to test BGP. So I'm not running OSPF on 1111 network. Alright, so this 1111 is for later. I'm just putting the IP address on the interface. I'm not running OSPF.
Okay.
Just a minute, please. Let me take this call. So nice call. Hello. Where is the number? Sir, is it new number? Okay. Sir, after 4:30, at 4:15, 4:15. All right. Thank you. So the IP address is supposed to be this IP address is supposed to be on F01. Default interface F00 will delete the IP address and interface F00 10.12.12.2 Okay, now going back to this configuration, R3, F00, this is okay. F01 is a WAN phasing interface. 200.0.0.1 and 250. No OSPF. I repeat, I am removing OSPF from F01 for R3.
Shouldn't it be 252 for the subnet mask?
252, right. That's right, you're right. Slash 30. Either 48 or it should be 52 because it's 30. Okay. Now, no OSPF on the WAN facing interface. No OSPF because it's WAN interface. Put this on R3. OSPF. We're going to use this network in BGP for testing. Alright, so if you notice here that 44, 44, 44, though it is class A, I have masked it completely because loopback 0. It's a loopback interface, loopback 44. The 144 network is also on the loopback interface, but I'm giving the class full mask for 144. It is slash 16. It's 255.255.0.0. And on F00, this is going to be 2. No OSPF here. Alright. Now what I would like to do first is IBGP. I would like to do IBGP. Between R1 and R3, the autonomous system number is this. I would like to do IBGP between R1 and R3. Let me begin from R1. When I say router BGP 1000, this router understands that I belong to 1000 autonomous system. Next, when I say you got a neighbor, see neighbor need to be manually configured. Neighbor need not to be connected directly. Is this R1 connected directly to R3? No. But neighbor need to be configured manually. Why? Because it's TCP protocol. You need to do this. You don't use any UDP to discover by sending hello packets. BGP won't send any hello packets. Remote AS 1000. What is this 1000 says? It says that this neighbor also belong to same autonomous system. If this number is same, then router 1 understands he is an IBGP friend. He need not to be directly connected. Now let me go to router 3. Before that, from router 1, I would like to ping this neighbor. This neighbor should be a pingable address. This need to be fixed first. If R1 cannot ping R3, then problem. So let us see why. Show IP interface brief. I want to check whether the interface is up first. It is up. Show IP OSPF neighbor. This is the problem. There is no neighborship between R1 and R2. Show IP OSPF interface brief. OSPF is running on this interface. Show IP OSPF interface. OSPF is not running here. That is the okay. Now I can see OSPF is running. Okay, I got the neighbor as well. So look at this. I can ping this neighbor which I have configured. I can ping. But BGP neighbor will not come unless you go and configure on R3. See, show IP BGP summary is the command to check whether neighbor is up or not. Show IP BGP summary is the command to check whether neighbor is up or not. If you see here, the neighbor is always it has never come idle. Never come. Let's go to router 3 and configure. Router BGP 1000. Neighbor 10.12.0.1. Remote AS 1000. Now you will see neighbor coming up. Neighbor will come up now shortly. Because this address is ping. It is not coming. You know why? Because this address is not pingable. I have given wrong address. You see, what is the right address? 10.12.12. I missed one 12 here. 10.12.12 is what pinging. So my neighbor configuration show IP BGP neighbor. No, don't put neighbor. Neighbor will show you some pages. Later we will see neighbor command. Now say summary. You see the neighbor again never come up because the address is not correct. Router BGP 1000. We cancel the old statement and we now say 10.12.12.1. Remote AS is 1000. Now I'm expecting neighbor to come up. You see, BGP neighbor is up. See, there is no PGP on router 2. See, show IP BGP. BGP is not running. But show IP BGP summary. You got neighbor here for last 14 seconds. Neighbor is up. You no need PGP in the middle in order to have neighbor between R1 and R3. So IBGP can be directly connected. That is what this proves. Now let's go to eBGP. Same router BGP 1000. Same command only. Neighbor 200 0.0.2. Remote AS 2000. So this makes the router to understand I belong to 1000, but my neighbor belong to 2000. So this guy is an eBGP neighbor. He needs to be directly connected. Ping and see. He's connected directly. So he's pingable. Now go to router 4 also. Router BGP 2000. Neighbor is 200 0.0.1. Remote AS is 1000. You will see, wrong. 1000. You'll see neighbor coming up now. See neighbor is up immediately. Let's go and verify in R3. Show IP BGP summary. You can see with autonomous system 2000, the neighbor is up for last 8 seconds. With autonomous system IBGP, see local is 1000. Neighbor is also 1000, which means IBGP, and this is EBGP. Any questions? We have done basic BGP configuration.
No, sir.
No
It
question.
was very clear. Understand good.